right, let's review some exponent properties. So first, let's just make sure that we understand what an exponent is and what it means. So here we have 2 to the 5th is equal to 2 times 2 times 2 times 2 times 2. 2 multiplied times itself 5 times. So here we have 2, which is called the base of the power. All right, next we have 5, which is the exponent. Let's try that again, exponent. And the whole thing put together is called a power. So it's the 5th power of 2. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. That's 4. So that's 16. And 16 times this 5th 2 is 32. All right, so let's look at some properties of exponents. The first property is the product property. That's when you're multiplying 2 powers of the same base. Notice that the base for both of them is x. This is important, okay? And we have 2 different exponents. The rule is that you add the exponents, okay? So in other words, when multiplying the same base, add exponents. And the reason for that is, let's say for example, if you have x squared times x to the 3rd, that would be x times x, that's x squared, times x times x times x, that's x to the 3rd. So putting it all together, you get x to the 5th. So let's look at a more complicated example there. First of all, when you have 2 things of the same base, or you got 2 variables that have, so we have w's, and we have z's, and we also have regular old numbers. For example, we have 2 and a -3. So the 2 and the -3 are just regular old numbers, so we just multiply them as normal. 2 times -3 is -6. Okay? W to the 7th and W to the -4th, we're going to add our exponents. That's going to be 7 plus -4 is 3. We'll review what negative exponents are in a minute. Then we have z and z squared. So z is really z to the 1st. So that's going to be z to the 3rd. All right, the quotient property. Let me open up a blank thing so that I can show you how this works. Okay, so let's say we have x to the 5th divided by x to the 3rd. What do we do with the exponents here? Well, x to the 5th is x times x times x times x times x. There's 5 of them. X to the 3rd is x times x times x. There's 3 of them. So what ends up happening here is we get some cancelization. These would cancel, these would cancel, these would cancel. And so our end result is just going to be those leftover ones, which is x squared. So what happens with the exponents is we are subtracting them. 5 minus 3 gives you 2. So x to the 5th minus 3 results in x squared. Notice that we're subtracting the top minus the bottom. So we have x to the a minus b. So again, you have to have the same bases. So when dividing same bases, you need to subtract the exponents. All right, let's do an example here. Notice again we have regular numbers of 8 and 12. Don't subtract those. Those are not exponents. 8 divided by 12, we can just think of it as like we're reducing a fraction. 8 is 2 times 4. And 12 is 3 times 4. So it's like the 4's cancel. So I have a 2 here, a 3 here. And now the x and to the 14th and the x to the 9th, I can subtract that. So that's going to be x to the 14 minus 9, or 5. And whenever you use that subtraction rule, it's going to be left over on the top. Let me make this a little smaller. So this is my answer. It's 2/3 x to the 5th. All right, let's talk about negative exponents. So going back here, let's say I'm doing that division, and I have it upside down. I have x to the 3rd over x to the 5th. So I have 3 x's on top multiplying over 5 x's on bottom multiplying. You still get that cancelization thing going on. Cancel, cancel, cancel. But what you have that remains is in the denominator. So this is 1 over x squared. There's a 1 here because when you do canceling, there's 1's left over. We don't multiply by 1 because it doesn't do anything. Okay, so if we were to use the subtraction rule, this would be x to the 3 minus 5, or x to the negative 2. So these are equal to each other. Okay, so essentially what happens is the negative exponent makes it go to the other part of the fraction. So this is going to be 1 over x to the positive a. Now if it's a negative exponent in the denominator, it's going to go to the numerator. So it's going to be x to the, so if it's in the numerator, it's going to go to the, denominator, it's going to go to the numerator. If it's in the, so you could think of this as the numerator, it's going to the denominator, okay? So negative exponent moves it to the other part of fraction. Or if you prefer, flips over. All right, so I've got some negative exponents here. I've got a to the negative 2. I don't want to highlight the 3. Okay, a to the negative 2. And I have b to the negative 4. Those things are negative, and they need to move. The 3 and the c are perfectly happy where they are. Do not move them. They do not have a negative exponent. Okay, so the 3 is going to stay. But this b to the negative 4th is going to go and become b to the positive 4th in the numerator. This a to the negative 2 is going to move, and it's going to become a to the positive 2. The c is going to stay where he is, and you're done. X to the 0 power. Okay, x to the 0 power is just 1. Anything to the 0 power except 0 is 1. 0 to the 0 power is undefined. So the reason for that is kind of back to that subtraction idea. If we are subtracting, like we're dividing, let's say we have x to the 3rd over x to the 3rd. Whoa, that got a little messed up. You get x times x times x over x times x times x. Everything cancels, 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 cancels. And so what's left over is just 1. All right, so that's sort of why. Whoa. So this one's an easy one to do. It just equals 1. So here we've got 3 times z to the 0 power. Now the 3 is not being taken to the 0 power, but the z is. So this is 3 times 1, which is just 3. Okay, then a power of a power property, you multiply the exponents. So this is when you're taking x to some power and then taking it to another power. So multiply exponents. So here we got x to the 4th to the 3rd power. That becomes x to the 12th. And then the next two are very similar to each other. You've got two things of different bases, an x and a y in parentheses, either being multiplied or divided, being taken to a power of a. So then here you basically give each of those things an a. Okay, so why do we do that? If I say have xy to the 3rd, that means xy times xy times xy. So you can see that there are 3 x's multiplying, so that's actually x cubed. Y is also, there's 3 of them multiplying, so that's y cubed. Now this only works for multiplication. It also works for division. If I have x over y, sorry, go away, to the 3rd would be x to the 3rd over y to the 3rd. So this would be x to the a divided by y to the a. You need those parentheses though, okay? So these are kind of the same thing. Give exponent to everything in parentheses, okay? So here we've got 3m to the negative 2n squared, so we're going to have 3 squared m to the negative 2 squared n squared. It's 9. Now these multiply, so that's m to the negative 4th n squared. Since we have a negative exponent, that means that this one needs to go to the denominator. So we have 9. N squared are going to stay in the numerator, but m to the 4th is going to go to the denominator. Let me write that again. Alright, and in this example, everybody's going to get taken to the 4th power. So we got a negative 2 to the 4th power, a k to the 4th power, so that's just in the top. On the bottom we have a 3 to the 4th power, and we have a j to the 7th to the 4th power. So remember that these are going to multiply. Power of a power multiplies. Okay, negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2. All those, like when you pair up negatives, they cancel. So this is really just 2 times 2 times 2 times 2, which is 16. Okay, so I have 16 k to the 4th on the top. 3 to the 4th is 81. J to the 7th to the 4th, you multiply the 7 times 4, you get 28. So this is the answer. And we're done with the review.